Okay, for episode 2 of Toby reads incredibly boring regulatory documents and tries to find the interesting bits out of it, I'm going to touch on the newly released FDA document, Testing and Labeling Medical Devices for Safety in the Magnetic Resonance MR Environment, and pull out what I think are going to be the useful bits for clinical practitioners. The first thing to recognize about this document is that it's not written for clinical practitioners. It is written for medical device manufacturers. If you're not making a widget and taking it to the FDA to ask for FDA approval and labeling for MR conditionality, this thing doesn't really apply to you. But having said that, there are a few really helpful little nuggets of information that do have direct clinical application. One of them is that the FDA is essentially saying that implants and devices, if it's less than 2 centimeters in any direction, it doesn't matter what it's made out of. The RF heating potential at field strengths 3 Tesla and below is unimportant. That itty bitty things, again, they give the dimension of 2 centimeters or less, and there's some information that suggests that may be very conservative, and there may be a little bit of safety factor above 2 centimeters. But they say 2 centimeters in all directions and at least 3 centimeters away from another object that may act as a conductor. If you're making these widgets, don't even bother doing the RF heating testing, because at 3T and below, we know that that's too small to experience resonant circuit heating. And so there's no peculiar risk for the implant or device other than what normally occurs with the patient's own tissues in RF exposure. So what that means for us is that the BB, the tiny solo little piece of shrapnel, the small foreign body, while there may be other safety concerns that are legitimate, even significant, the concern with respect to RF heating, again, 2 centimeters in any direction, 2 centimeters or less, the concern with respect to RF heating is essentially non-existent. They also go on to describe labeling for the duration of scanning, right? So the typical ASTM testing methodology calls for a pulse sequence that is 15 minutes in duration to measure the heating. Now, if they don't explore what the heat dissipation is or what the maximum thermal accumulated load is, then in theory there's supposed to be a a pause period between 2 sequential pulse sequences. This document goes on to describe when a pause may be indicated or when you can ignore it, and essentially you can auto scan and go from A to B to C. And they essentially say they differentiate whether the implant or device, the foreign body, is in thermally sensitive tissue versus not particularly thermally sensitive tissue. If the heating is 2 degrees C or less in thermally sensitive tissue, 4 degrees C in non-thermally sensitive tissue, if that temperature rise in a 15-minute period of continuous exposure at whatever the stipulated SAR value or B1 plus value is, if the temperature rise is 2 degrees C or less, then there's no pause really indicated. 2 degrees for thermally sensitive, 4 degrees for non-thermally sensitive tissues. If within a 15-minute period the temperature increase is greater than 2 or greater than 4 degrees, then there's supposed to be a pause between successive pulse sequences. But as long as the temperature increase over a 15-minute period is no more than 2 degrees, no more than 4 degrees, then a pause between pulse sequences is not indicated. And then the last thing that they provide in this document that I think is really helpful to clinical decision making is they talk about gradient-induced heating. And they talk about how it's really only applicable as a safety concern under some very limited circumstances. But then they talk about, there's a statement, due to the rapid drop-off of the gradient fields outside the MR system bore, gradient-induced heating does not pose a thermal hazard for medical devices located outside the bore. So incident gradient energy, once you get outside the face of the bore, is small enough that it doesn't represent a concern, at least with respect to gradient-induced heating, which is only really an issue under some very limited circumstances, according to this document. So, in summary, FDA in this document says metallic implants 2 centimeters or smaller in any direction, and not part of a cluster, so the onesies, you don't need to worry about RF heating. Period. End of statement. Then the second item, pertains to the delay, pause between pulse sequence, whether it's indicated or not. And as long as the temperature increase in the tissues adjacent to the implanter device are no more than 2 degrees C for thermally sensitive tissues, and no more than 4 degrees C for non-thermally sensitive tissues, then there's really no safety indication for a pause between pulse sequences, and you can run them like freight trains. And then the last item is that incident gradient energy drops off so quickly by the time you're outside the bore, at least in this document, with respect to gradient thermal concerns, nothing outside the face of the bore. Now, what would I like to see them expand on? The information about sort of the face of the bore. This is kind of a rule of thumb that several of us have been using for a period of time, saying that once you get outside the face of the bore, incident energy, and they talk in this document specific about time-varying gradient heating effects, which are so infrequent and peculiar unto themselves. But I think that this could be, and I hope that the FDA at some point will expand upon this and use the face of the bore as sort of a rule of thumb for not just gradient-induced heating, but all gradient-related concerns. And similarly, for radio frequency energy, that they would use the face of the bore as sort of a rule of thumb for incident RF-related concerns. Now, both gradients and RF, once they enter the body, enter an electrically conductive media, they begin behaving like electricity. So what I'm describing here are risks of incident power, but there is the potential, if there was, say, a lead or an electrical conductor inside the body of the patient that was partly in the volume of the bore and partly out of the volume of the bore, that conductor could still convey the power that was deposited over here, travel over there. So it's not that we have no concerns when an implanter device is outside of the face of the bore. It's when the entire implant assembly, the entire electrically conductive pathway, is outside the face of the bore. But it would be my hope that in future, since the FDA has kind of broached the topic in this document, in future it would be my hope that they more explicitly give us the landmark of the face of the bore as being sort of a demarcation point for where we do or don't need to be concerned about RF or time-varying gradient incident energies and the safety consequences thereof. Anyway, I hope that this is helpful to you. I will try and include a link to this document in the comments below. And whatever you do, don't tell my boss that I stole his office again to record this video, so that I'm a little further away from the jackhammers and the beeping backhoes that are out in the front of the building. I hope they weren't too obnoxious during the recording. Thanks.